right now. My name is Pablo Dorado, and today we're going to talk about uh, chain extensions. Chain extensions and how does it work with smart contracts? Okay, and Zombienet. Uh, we'll be using Zombienet because it's way easier to use Zombienet than to try to remember what are the commands for booting up the node. So we'll be using Zombienet. You can download Card Contract on the webpage of Inc. And you'll be able to download Zombienet. Here's how to install it using npm. Okay, let's get started. Chain extensions. Basically, what are chain extensions? Chain extensions is defined by Inc. Themselves as a joint as an union between the parachain runtime and Inc. Between a smart contract and the parachain runtime. Basically, the parachain runtime being your parachain, your blockchain. So if you are a parachain developer, you might be interested about this. If you're a contract developer, you might be interested about the parachain that supports chain extensions. And what is this under the hood? Basically, it's all about passing messages. So you are a user and you call a contract, but how does the contract get access to pallets? There are two ways of accessing the pallets. First of all, you can make calls, but calls are asynchronous. So you guarantee that the calls are being you guarantee that you are using, and also you are using calls as is. You are using calls on behalf of the contract address, but we'll get to it a bit later. Instead, if you use chain extensions, you'll have something in between. Basically, an intermediary that helps you get to the full potential of the blockchain without having to pass through these end user endpoints of the pallets, which are the calls, and get to the bottom of the pallets themselves. I'll show you how does that work in a moment. So, what can you do with chain extensions? Depends on who are you. If you're a runtime developer, you might use chain extensions to design an API that allows contract developers to extend what your users can do on your blockchain. Basically, if you have used Inc. in the past, you might be noticing that you, in a contract, can receive funds, you can move funds, but native token funds. You can store values, you can emit events. That's pretty much it. Store values, read values. That's pretty much it, right? But we're about interacting with the blockchain. We're contracts in the end, if not a means to extend an interaction of the blockchain. So if you're a runtime developer, you might be enabling contract developers to extending the blockchain. If you are a contract developer, you might be able to interact with the blockchain with a more specialized API, and the API for the blockchain. Today we're both. We'll be exploring both sides of the story, and Before we get on to the code, just a small reminder, as Uncle Ben used to say, with great powers come great responsibility. If you have to be mindful about the potential and the great power that you can have on the blockchain if you allow users using the palettes without the protections that are usually provided in the palette calls. For example, and as we'll see in this example, you might be able, for example, to call them. Let's continue. With great power, because you're being able to access directly to the flesh and bones of your blockchain. With the chain extensions, you have to be very careful about what you're giving access the contract developers to your blockchain. Okay, what we're doing today? We're doing. Do you know about NFT airdrops? Something like, hey, you can grant NFTs, for example, to people who attend to an event, and that's something like that is what we're doing today. Basically, it goes like this: you create a contract, and when you create a contract, you will call this create NFT collection call on the chain extensions, and it will call directly to the NFTs palette to create a collection for you, and it'll retrieve the collection ID for you. Once it retrieves the collection ID for you, you'll be able to store that collection ID in your contract storage, so you know it afterwards. And we'll have a counter of the items, because we're minting NFTs for people who call this method called Airdrop NFT. So if you're a user and you call in the contract Airdrop NFT, and you do that, it'll go to smart contract, and the smart contract will call the chain extension method create item, which itself will be calling the palette NFTs mint method, and it'll return the item ID of the minted item, and you'll be having the item ID back to the contract, and the contract will prompt an event saying, "Hey, your NFT has been created. This is the ID. Congratulations, you have an NFT airdrop." And this is what we're gonna do. So let's get to the code. Okay, we're starting halfway to the before we start, we're starting halfway in the code. So we have this basic implementation of a runtime that includes the chain extensions already defined on the runtime end, but we're going to implement in this workshop the contract end of the runtime of the chain extensions, and we're going to implement a sample contract. So okay. So what do we have here? First question, what do we have here? We have the chain extensions, and it's basically a structure you define on the runtime end, and you implement this call method, which is part of the chain extension trait for palette contract chain extension. Chain extension includes all the traits and all the types that are necessary to implement chain extensions. Okay, and we'll have the chain extensions for T. T is a configuration. If you're familiar, somewhat familiar with Substrate already, you'd be able to understand what this T means. But for now, it's just T. T is the runtime.
Hey, Pablo, can I just interrupt you a sec?
Yeah, sure.
Could you zoom in on your code so that people can read it a bit clearer?
Sure. Better?
One more time. Amazing. Thank you.
Awesome. Perfect. Okay, let's continue. Chain extensions. This method call is basically the center of it all. Is basically a controller because it receives very basic things on the message passing between your contract on Ink and the runtime. Basically, what it passes you is a really long string encoded in scale that gives you the extension ID, the function ID, and the origin of the signer, of the color of the contract. So you can get the account ID of the contract. And also, it depending on which function you called in, it'll get you some arguments like this one, for example, collection ID, item ID, who. Okay, so let's get to the first method, create collection. The first method, create collection, basically what it'll do is just go to the palette NFTs and it'll call directly to the API defined create collection. This is not the create method you call on palette NFTs on the browser. This is the inner call of NFTs. Remember what I told you about with great power comes a great responsibility? For example, let's go to see what is in the configuration of NFTs. As you can see, all these NFTs has a balance, has a deposit cost of 0. So basically, it's free to create NFTs in this example chain. This is for practicality, but also this is to show you that you can basically do whatever you want on with these chain extensions. I could configure, for example, 2 palette NFT instances, one that is public for everyone and one that is only reserved to contract coders that allow to the contracts to create NFTs for free. This is a compromise, obviously, and you can have other means to control that people don't spam your blockchain, basically, by creating lots of NFTs. But yeah, that's it. You create the collection, you retrieve the collection ID, you write the collection ID onto the output, and that's it. That's your call for create collection. That's what we define already on this pretty clever diagram. So there's create item. Oh yeah, this one, this create collection. Then there's create item. You airdrop an NFT, and within the smart contract, you call a chain extension, which will call mint, and you'll get the item ID. You'll get back the item ID, and this is what we're doing. Okay, this is not collection ID. This should be item ID. I'll push right away for you. This is item, and it'll return you the item ID. So basically, that's it, the item ID. So if you, and as I told you earlier, you can get arguments on the function, you'll be using this read as function of your chain extension environment to read the input you receive from the contract and encode it and decode it to a tuple of arguments. That's basically how you parse, how you process the input arguments. And how do you put the output arguments? As this. It can be a single output. It can be a tuple of outputs. If I wanted to, let's say, item ID and the cost, for example, what costs you to get this NFT? It's free, so it's a tuple. You can encode it and then write it back to the contract. But that's a part of the runtime. I'll zoom in back in a couple of minutes, but before that, let's create our contract. So we'll create a contract using cargo contract, new contract. Easy as this. And there we have it. A smart contract created with ink. We'll know about this and we'll be back at it in a couple of minutes. But before, we have to define our chain extensions, because there's also a chain extensions point of view from the contract end. This is usually tied up to library, to external library, but for practicalities, it'll be here within the extension, within the contract. Okay. What do we have to define here? Basically, we'll have to define, first of all, define this contract, define this module, chain extensions, and that's it. We'll add this to the workspace. We'll add this to the workspace. Okay. So we can get access to Rust, basically. Okay. And we'll start by defining ink chain extension. Oops. Yeah. So we'll say that the extension is 1. It doesn't matter. This is just to allow.
Can you just zoom one more time again?
Sure. This is okay. This extension ID, this extension number, I just put here. Portrait. My chain extension. We'll call it like that. NFT chain extension. This is to allow if we have multiple chain extensions, like one extension for NFTs, one extension for dealing with assets, one extension for maybe, I don't know, voting on OpenGov, something like that. We'll have different chain extensions, and we'll be able to access to the extension ID via this variable called extension ID. Oh, okay. Let's go back to it. What's down here? Okay, and what are we going to define in this trait? Basically, we're going to define this structure we want to define for the calls. Basically, it's a contract. It's our interface, our contract between the smart contract and the runtime. This is the chain extensions itself, and we're going to define function 1 because we're already defined somewhere over here that create collection is 1 and create item is. So basically, that's what we're going to do here. Function 1 will be create item. Create collection. And there are no input arguments, but instead we're gonna get an U16, which is the kind of which is the collection ID. We'll see it right here. Collection ID. Sorry, it's U32. And we'll get the. We can call it. Give me a second. There. We can call it collection ID right here for variety and for more readability. And we can have item ID, which is also U32. We'll use it in a second, and we'll receive and that's it. We can also create an item, and here things will change a bit because we're inputting some arguments. Which arguments? You might ask. Okay, first of all, what did we define here that we were going to receive? The collection ID, the item ID, and who is the recipient of this NFT item. So collection ID is basically collection ID. The item ID is basically an item ID here, and who is the account ID 32 type that is defined somewhere over here. We can define it here. And that's it. These are our arguments, and we'll be able to get them. So this is the function number 2, create item, and that's it. We already defined our extension on the contract end. Okay, but is that enough? We shouldn't be having anything else. Of course, we should have something else. We'll go right here to the contract we just created, and we'll define an environment. But before that, we'll create the definition for an environment here. Environment basically let us configure the collection of chain extensions we have in our contract environment. So my environment, chain environment, something like this. Of course, we define a model environment here. And let's implement environment. Which is We'll define environment for our chain environment. In here we can define types. We have to define some types. Account ID, its default environment, as environment, account ID. So we'll use this to extend the environment from the default environment. I'll do this. Basically, I'll get this. And once we define all these base types that are related to the environment, oops, where? Ink is working here, yes. Huh. Yeah, Ink is giving us a couple of problems here, but we'll be able to. So now we can define which is a chain extension we are using here, and we'll be referring to NFT chain extension, which is already defined here in the grade. Chain extension, NFT chain extension. And now that we have defined an environment that uses the NFT chain extensions, we can now use the environment in our contract. So we have contract. So I have the contract library. I'm going to extend this contract. You probably have already seen somewhere, and we'll use my chain environment. Chain environment. Okay, what else? Now let's get started, and let's gonna use this this environment in a program. So as we said before, as we said earlier, we're going to store our collection ID, and we're going to store our item ID. We'll be incrementing the item ID. We'll be controlling that within our contract. For now, item ID will be 0, and collection ID will be 0, but we'll get back to it in a couple of seconds. And that's it. We'll define collection ID, and we'll be making a call to get the next to call a message. That initializes the collection. This will require a result, so we'll return a result. And for now, we just put OK. And OK, what do we do now? So we have our environment, and our environment has this method extension. And what is this method extension, you may ask probably? Exactly. These chain extensions we have here. So we can call create collection. Define the collection ID. And that's it. We can now assign. Now we can assign self collection ID and write the collection ID from what we have already received. To self. I just forgot self. That's why it's not giving me this. Okay, that's it. And now we can assign the collection ID. We can save it for later. That's it. And now let's go back to the airdrop NFT method. So we'll be receiving the color using what we already know about receiving messages. Perfect. So we'll be able to use, in this case, we'll be able to use, we'll be able to create this airdrop NFT method that will define the following. Okay. Let who is a color. And color. This is the account which called the contract in first place. And now we have the collection ID and the item ID. We'll be incrementing the item ID because we already have 0 item IDs. We'll want to find the first item ID, self item ID plus 1. Or we can just do the same with self item ID equals self item ID plus 1, and we'll be able to use item ID directly on the call. Okay, now we have item ID, because if anything happens, we'll let the user know that something happened, and that'll help us. And try and resolve. Okay, we have these testers. We can have these testers. Okay, the item ID, and we have the collection. We have the collection ID. We have the color, and we have the item ID. Okay, let's call this. We're going to retrieve the item ID from. That we received from the chain extension, and we're going to verify that this item ID is the same item ID that we sent it. This is just a sanity check. And we call self environment, and now we have extensions, and we can call mint create item. Create item receive 3 parameters: self collection ID, self item ID, and who. If it all works out, it'll return you the item ID, and we'll be able to check if item ID equals to self item ID, and if it is, we'll be good. We can just emit an event. And so let's define an event. Let's define a small event here. NFT minted or NFT airdropped. Who is the account ID? And the ID will give the user both collection ID and item ID, so the user will know where to find it. So it's a collection ID. This is an item ID, and that's it. Now we can emit the event. So emit event, and we can use NFT Airdrop. Collection ID is self collection ID. Item ID is self item ID, and who is basically who. There's not much to do about that. And we return OK. But what if the item ID is not the item ID we were trying to get? We can emit an error, and we can do it to let the users know that something happened, that this was not what we were expecting. But in this case, we'll just assume that the item ID is the same. Okay. So for now, this is it. This is the base of the contract. I don't know so far if you have some questions about it. If anyone have some questions about it, let me know. Otherwise, we'll continue. Okay. We'll try to. Okay. So next thing we'll do is we'll try to cargo contract. Let's see what we can do with cargo contract. We can build the contract. Yeah. It says here that cargo metadata can be built because we have a different version of wasn't up, and we need Bernarian was a builder. So yeah, let's use Inc version 5 for this example. Don't mind about what cargo contract gave us here with 4.2.0. We'll be using version 5. Oh, now we have this. Haha. We have our first errors. Chain environment must direct clone is empty, so it will do that. It will satisfy it. And let's see what else. We have several errors. We'll check them. Okay, use of undeclared environment. Environment is here. Oh, we can use create environment, of course. Create collection takes 2 arguments. The one was supplied. Oh yeah. This is result ID or error code. Yeah. Basically, here we're handling this. Results will return either okay with a collection ID in this case, or okay with an item ID in this case, or the error code, which we already find here. There. What else? It's the same here. And the clone. Let's try again. Now we have here result. Oh yeah, airdrop. Airdrop has the same. Further, we have the same. We are defining result here, but it should be an error. We're gonna say here we're going to use an U16 because we already find in this environment, not here in the extensions. Sorry, U32 as our code, and same thing here, U32. So we have results here. Let's try again. There. Okay, this is. It says that this is ambiguous. Whew. Okay, it's suggesting us to use this extension instance, but this is we can't access this portrait. Now we have the extension and expected, but it's account ID. And account ID is a struct that will be defined here because we now have this primitive of account ID. Oh yeah. So this is it. this shouldn't be ambiguous anymore. Oh, it is. Handle stars through. Okay, this is something I forgot. I'll just do it right away. And this is basically an error handler. And we have this NFT error. And we have this rewrite. And we can now translate it to something that, but we'll not be using this. Create collection. Can create item. Match error code. There are just two. Can create collection, can create item, that's it. And we have this NFT error. We'll be returning this NFT error. From status code, NFT error. Okay. That's it. So yeah, now we're able to handle these error codes. We have to derive this to handle the errors, to handle the scale errors. Just in case it doesn't decode correctly to an error. And that's it. There we have it. Our chain extensions. So convert it to the U32. Will we able to convert it back to U32? the error. Now we can map it back. And we have here our account ID. We don't have to use this account ID 32 anymore. Anything else? Oh yeah. Great. U32 from error. This works better. Two extensions. Now we can convert data. Now it should work as E-into. It's not working. Now I'll tell you explicitly, this is U32, so you shouldn't fail. That's it. And let's leave this for verification that will happen after. So functionalities behind a self-reference. Because this is U32. Oh yeah, we can mutate. We have to mutate the self. Now it's just one left. Let's add another leg here. Let's say solid. No errors. Now we can compile this thing. Huh. Okay. Next steps that you basically, for timing reasons, I can't do them right here. But basically, what we can do is just go to Zombienet and spawn the Zombienet. We're going to create an instance, a local instance of our chain in Zombienet, and with that we can use cargo contract upload. I'll leave the link of the repo on the chat so you can go check the code, see how it works, and try it at home. I'll push an update with the fix really soon.
So that brings us to the end of the Polkadot Inc. Bootcamp. For now, congratulations to everyone who has made it through all of the live workshops and been completing the homework. You will be eligible to graduate. I will be sending around the information on how you do this very soon. Yes, some celebrations. A big congratulations, a massive thank you to all of the speakers who we had in for workshops, Pablo being our final one. And I hope that you guys who are new to Encode Club want to check out the other boot camps and programs and hackathons that we run. Coming up soon will be a Polkadot hackathon, which I'm sure you'll be hearing about. So if you are interested in participating, then keep an eye out in your emails, because I will be emailing you as soon as the application process for that is live. And hopefully we can see you implementing some of the things you've learned on this bootcamp in a hackathon. We'd love to see that. So once again, thank you, Pablo, for joining us today. Well done, everyone, for completing the bootcamp. And unless Pablo has any final words, we'll end it there.
Well, now I hope you guys have enjoyed, and I hope you make great code.
We love that. Okay, awesome. If I see you again soon, then that would be great. Otherwise, goodbye, everyone.